Hi, grade 11s. Today we're having a lesson again on analytical geometry. This lesson is on parallel lines and perpendicular lines. Lines like that which don't meet are parallel, and lines that meet at 90 degrees we say they are perpendicular. In analytical geometry, we say when lines are parallel, their gradients will be equal. The number, usually this is represented by number, so m1 will be equal to this m2 here. You'll be given as a number m2 there. However, lines are perpendicular. The product of the gradients will always be -1, meaning if I take this gradient here, which is -1, if I multiply the gradient of this other one, which is m2, the answer will be equal to a -1. Let's look at how some of the questions are asked, and you'll expect some like this as well. Here's an example. It says determine whether the two lines below are parallel or perpendicular to each other. So the first thing that you do, you write the line, equation of a line in a standard form, just like these ones here. So obviously here I've got to change this and write it nicely. So you can see here that this becomes 2y equals, take this across, is -3x, then plus 12. If I divide by 2, I get y is equal to -3 over 2x, then plus a 6, because I divide everything by 2. If I take this one here, I'll write in the standard form. I'll take the -10y to this side so that I've got y. So it's a positive 10y is equal to, take this one across, it's -15x, then plus 20. If I divide by 10, each term here, I get y is equal to -15 over 10x plus 20 over 10. If I simplify this, I get y is equal to -15 divided by 10. You can use a calculator to check that. Your answer, because 5 goes there 3 times, and 5 goes twice, x, then plus 10 goes there twice. If you look at the gradients, the gradient here is -3 over 2, and the gradient here is also -3 over 2. The gradients are equal. These are gradients. Right? So if the gradients are equal, we can conclude that the lines are parallel. Let's look at another example. Here's a nice example. It says determine whether two lines below are parallel or perpendicular. A similar situation. Let's check here. Write standard form. So it's 4y is equal to, take this across, -3x plus 12. Divide by 4. Y is equal to -3 over 4x, then plus 3. If I take this one here, I divide here, I get here y is equal to 20 divided by 15 plus 10x divided by 15. If I rearrange this, I'll get 10x over 15 plus 20 over 15. If I simplify this, I get y is equal to 10 divided by 5 goes there twice, 5 goes there 3 times x, then plus 5 goes there 4 times, 5 there goes 3 times. If you look at these gradients here, this gradient here is not the same as this gradient. Even this is 3 over 4, this is 2 over 3. Even if we multiply them, -3 over 4, if I multiply that, I get 2 over 3. I multiply this, so this becomes what? A -6 over 12. I get an answer of a -1/2. I don't get an answer of -1. In this case, we can say that the lines are not parallel or perpendicular. They would have been parallel if those gradients were the same, or they will be perpendicular. If when I multiply them the answer was a -1, then I would have said they are perpendicular. Now let's look at another example. It says find the equation of a line that is parallel to this one. Okay, in standard form. So y is equals to 2x minus 4 if I take this to the other side. Standard form. So for the lines to be parallel, we say they must be having the same gradient. So the gradient of the other line that I'm looking for must also be 2. Therefore, I can start by saying y is equals to 2x. What I don't know is the y-intercept, is the c value. To find the c value of this new line, therefore I'll have to substitute that point there. X is minus 8, y is 5. So 5 is equals to 2 times x, which is minus 8, then plus c. So 5 is equals, if I multiply there, I get minus 16, then plus c. Take this across, you get 5 plus 16, which is equal to c. So that is 21, which is c. So our c value is 21. So I can just plug this c value over there, and therefore the equation that they are looking for is y is equal to 2x, then plus 21. Let's look at another one. It says find the equation of a line that is perpendicular to this one. Again, standard form. 3y is equal to a minus x plus 12. If I divide by 3 or both sides, I'd get y is equal to minus 1 over 3x, then plus a 4. Now, this is standard form of that line. So the new equation that I'm looking for, I can say now, because I know that the lines are perpendicular, the product must be minus 1. So the gradient for the other one, I'll have to change the sign. If this is negative, the other one now will be positive. Then I'll have to twist this thing around so that if I multiply, I get a -1. So if I turn them around, so I'll have a 3 over 1x. Then plus a c, because I don't know the c, the y-intercept of the new line. So to find the y-intercept of the new line, now I must substitute the point that the line is on. So x is 5, y is minus 7. Minus 7 is equal to a 3 over 1 x, then plus a c. But when we said the x, we know x was a 5. We got 5 there. So minus 7 is equal to 3 times 5, which is a 15, then plus a c. So if I take a 15 across, I'll get minus 22 is my c value. So the c is minus 22 in this case, and therefore I can write the equation and say y is equal to 3x, then minus 22. Let's look at another example. This example says find the equation of the line f and g. Now if you look at the lines here, this is the line, and I don't have an equation, but what is important is about the gradient. But what I know about this line is got 30 degrees, which is an angle over there. We know how to work out the gradient if we're given an angle. Remember the formula which says m is equal to tan of theta. That gives us m, which is the gradient. So the gradient of this line here, m is equal to tan of 30 degrees angle of inclination. Therefore, if I use my calculator, I can find out what is m is equal to 10 of 30 degrees. So I got 10 of 30 degrees. I get an answer of square root of 3 over 2. So the square root of 3 over 2. Don't panic with the square root things there. They're fine. We'll sort it out. So now, how can we solve this now? So we say that this line here is perpendicular to this. This gradient is for the blue line. Let me write here. This m is for this one here, which is root 3 over 2. So because it's perpendicular to the green one, let me use a green pen. So it means that I can now say the equation for the green line is y is equal to, because they are perpendicular, change the gradient around, and then it becomes negative, and 2 over a root 3. Note, one is positive, the other one is negative. If they are perpendicular, then we turn the numbers around. So there is a gradient, then x, then plus a c. Now to find the c value, I'll have to substitute the point which is on this green line, the y and the x. Here is the point. The y value is minus 4. Minus 4 is equal to minus, then 2 over root 3. Then I substitute the x value, square root of 75. Then plus a c. So minus 4 is equal to, if you've got a calculator, you can get this answer here. So what is it? It's minus, then we've got a 2 over square root of 3. Square root of 3, then which is bracket there. Sorry, let's go back. Then it's a bracket, which is square root of 75. Then you close, and the answer something went wrong there. So this thing here went wrong there. Let's go, let's remove this. So there I put square root of 75, go out, there we go, and the answer is negative 10. So negative 10 plus a c, which therefore means now I can take a minus 10 to the other side. So it's 10 minus 4 is your c value. So the c for this green line is 6. So which means that I can take this 6 and put it over there. So the equation that I am looking for is y is equal to minus 2 over 3 square root of 3x then plus a 6. Now let's look at the red one. The red one says we've got a line there parallel to this one. We said that when lines are parallel, the gradients would be the same. So the gradient of this line will be the same as this one, but the gradient of this one is this. Therefore, to find the equation of the red one, we can say y is equal to, using the same gradient as that one, is square root of 3 over 2x then plus c. Now what is c? C is the y-intercept. If you look at the red line, it's cutting the y-intercept at minus 10. So it's just exactly that number. So it will be y is equal to square root of 3 over 2x then minus 10. Done. Let's look at the last one. The last one says if the line y is equal to 7x plus 8 is parallel to the line y is equal to k minus 4x minus 6, find the value of k. How can you find value of k? They say the lines are parallel. Now if the lines are parallel, it means that their gradients are the same. It means that this gradient is the same as this gradient because they are parallel. We can say therefore k minus 4 is equal to 7. We can then say k is equal to, take a 4 across, is 7 plus 4, so your k value is equal to 11. That's what they were looking for. Let's look at the other one here. They say if the lines minus 3x plus 4 line is perpendicular to this one here, find the value of p. Now if the lines are perpendicular, we said the product of their gradients is minus 1, meaning if I take this gradient and I multiply with this gradient, the answer will be minus 1. So we can say therefore, because we know they are perpendicular, the minus 3, if I multiply with this one, which is a p plus 3, the answer will be equal to minus 1. How to solve for p? Some will remove brackets. That's fine. Let's do the normal one. They multiply by this minus 3p. Multiply with this is minus 9 is equals to minus 1. So minus 3p is equals to minus 1. Take this across is plus 9. So minus 3p is equal to 8. So what's the p value? I'll divide by minus 3. So p is equals to 8 divided by minus 3. If you like, you can write it as minus 8 over 3. Okay. On your own, guys, this is so simple. It's the last section on the book. Your work on your own from Siavula Maths book for grade 11, chapter 4. You do 4.4 and 4.5. It's parallel lines, exercise 4.7. The perpendicular lines would be 4.8. That enjoy. They're easy to do. Good luck.